Artificial intelligence has been evolving over the last 80 years, and yet recently it seems to have exploded onto the scene with force, tangibly changing the way utilities operate, the way assets are managed, and the way workers spend their time. To gain insight into how AI is disrupting the utility space, as well as the risks and opportunities of digitalisation, I'm joined by Carol Johnston, VP of Energy, Utilities and Resources at IFS. We talk about why AI is critical to the energy transition and how to mitigate the increasing power demand that AI is placing on the grid. Carol also paints a picture of the future interaction between humans and machines and highlights how we, as mere mortals, can prepare for that future. I'm Pamela Largue, and this is the Energy Transitions Podcast. Carol, thank you so much for joining us today to talk about what is one of the most popular topics on everyone's radar, and that's artificial intelligence. But before we get into the nitty-gritties of the topic, tell us a little bit about yourself and your role at IFS.
Hi, well, thank you for having me here today. And I'm the Global Vice President for the Energy, Utilities and Resources industry at IFS. It's a great role, as my main responsibilities are to engage with our customers around the world, learning about and sharing what's happening in these sectors, what are the major trends and challenges shaping these organizations' futures, and leveraging that knowledge, working with our R&D, our research and development, marketing and sales teams to build out innovative, but I think even more importantly, relevant solutions that we can then take to market.
My first question to you, Carol, is why has AI suddenly exploded on the scene to such a degree? It's not a new concept. It has been around for a while, but all of a sudden it's on everybody's radar. Why is that?
Yeah, it does seem like AI exploded onto the main stage overnight, didn't it? But really, it's been slowly evolving and maturing for a long time now, as you mentioned. I mean, the world saw the first artificial neuron or brain cell developed way back in 1943. That's over 80 years ago. We saw Alan Turing, the gentleman who broke the Enigma code used by the Nazis in World War II, and he developed the first test for artificial intelligence in 1950. Eliza, the first chatbot, interestingly enough named after the character Eliza Doolittle in My Fair Lady, was developed at MIT and released in 1966. And sadly, I'm pretty sure some organizations like my cable company still use Eliza today. At least I've been stuck on the phone with some of these chatbots. But 2002 saw the introduction of the first AI-powered vacuum cleaner, which spawned the explosion of cat videos and memes. But, that's probably another story for another podcast. We saw IBM's Watson defeat 2 human contestants on Jeopardy in 2011. The next generation chatbot, Eugene Goostman, was developed by a group of Russian and Ukrainian scientists back when they still got along, and successfully passed the Turing test in 2014, 64 years after its first invention. But things really kicked up a notch in 2015 when Amazon introduced the first AI-powered personal assistant, Echo. We could use AI to control our homes and our lights and shop online. So while it's suddenly seemed to emerge, and it certainly has exploded onto the utility scene pretty dramatically in a short period of time, I think that's fueled both in part by a maturity of the technology, but also the pressing need of the organizations when they were faced with the transformation of their 125-year-old businesses to a clean energy future before the impacts of climate change take over us.
We're in a situation where, like you say, these 125-year-old businesses are having to transform quite dramatically and green their operations. Tell me, do we need AI for the energy transition and for decarbonization?
I think it comes down to both the scope of the transition that's required, but more importantly, I think even the timeline. So we're faced with such a compressed time in which this transition needs to occur that the need and the complexity of managing the future state of the energy grid, when you look at billions of distributed energy resources and a two-way energy flow, it's absolutely reliant on a corresponding digital transformation. It's not enough just to change our business processes or the assets out there, we need to look at managing the grid differently. And AI in particular is shaping up to be, frankly, a huge game changer in this industry as well as a lot of other industries. And it's enabling better insights and decision making support, obviously, but also filling in the gaps in resource availability and experience that's been fueled by boomers aging out of the workforce and the lagging interest in joining the industry from the next generation.
We will certainly be talking about next generation workforce a little bit later on. But I want to touch on something. Carol, you talked about how AI is allowing us to manage the grid differently. And I think I want to focus on the grid because with the increasing use of AI, and of course, a lot of the data centers that are springing up to support this digital journey, there is so much pressure on the grid. It's being pushed to the max. So how do we manage that?
Yeah, it's kind of a double-edged or frankly even a triple-edged sword, isn't it? No one has ever built the grid out to support the amount of capacity that's been sold. That would just be cost prohibitive and infrastructure prohibitive. And when you're seeing the demand curve spike and shift from electrification initiatives and demographic growth, but for sure data centers with their geographically concentrated load profile and 24/7 operations. It's great for business when you're in the business of selling power. And of course, utilities themselves are becoming bigger consumers of these data centers. But how do you build out a grid able to handle those kind of loads without blowing the roof off affordability metrics? One way is through obviously careful planning and partnership with communities in the industry, such as when data centers are planned and come online. I've seen a lot of organizations and utilities around the world incorporating renewables into the construction so that they can offload some or all of the load during peak periods when the grid is under pressure. And we're seeing that in residential and other commercial aspects as well, where they're renovating or bringing those construction infrastructure up to speed. But certainly, if you plan it from the ground up when you're building a new data center, that makes it a lot easier. And once we solve this load issue, I think commercial fleet EV charging is the next big mountain to climb. Where can these stations be located? And who should fit the bill for building out the required capacity to handle that load?
Carol, I think that's a great segue onto my next question, which is where in the utility space are you seeing the biggest impact of AI or the biggest disruption? When I was preparing for this podcast, it became very obvious that there's a lot happening, whether it's demand side management or interacting with the customer. Where are you seeing most of the disruption?
Yeah, well, 80 plus years on since its first introduction, how are we seeing AI being leveraged and envisioned in the utility sector? And, I think it does run the gamut, from business and grid analysis and planning to automating and improving customer service, all the way to advancing field maintenance and service activities. Imagine being able to analyze, predict, and respond to asset failures before they happen. That's no longer fiction, but fact. Or a system recommend crew compositions or deployments to match forecasted workloads in regular operations or during major events and storm situations. The opportunities are quite literally endless. And we really need to focus on, where are we going to get the biggest, disruption and bang for our dollar. At IFS, we're not in grid load management, but we're focused on 6 key themes and utility use cases that we're hearing from the industry. The first is around forecasting and simulation, being able to forecast events, damage to critical assets, stage, crews and repair activities, forecasting and doing the analysis demand by type of work and location, priority, seasonality. A lot of our customers are college and university towns where they've got seasonal demand with the big move in and move out of campus, looking at those models requiring the capacity against forecasted demand. And then developing inventory and equipment requirements. It's not just about the workforce or the assets, it's about staging of that material in inventory so that you're not over shoring up available inventory, but you also have the available equipment and materials when you do need them against the planned work schedule. The second area around optimization, I mean, this one's been around for a long while now, and I think was one of the first based use cases for utilities to schedule and route optimize their work orders. But this technology continues to evolve and now supports dynamic scheduling, considering new workloads and service level agreements throughout the day, not just overnight runs. And also considering we were talking about EV earlier, and a lot of the utilities have electrified their fleet. Now these optimization and scheduling algorithms can consider EV charging stops in route and much more. We're also looking at route planning in support of carbon offset calculations. So, ESG reporting and being able to not only reduce the carbon impact of their operations in terms of the power generation, but also, their fleets and workforce service activities throughout the day. Looking at automatic bundling of work at the same locations, avoiding multiple truck rolls and visits for efficiency, fuel reduction, and carbon offset. And then looking at restoration activities, utilities around the world are being hit with the effects of climate change. So looking at restoration activities after a major event, considering and calculating into that optimization algorithm critical customers. So, where are your hospitals, municipal centers, a number of customers impacted, and other criteria that goes into the sequence or the order in which you want to do your restoration activities. The third theme or area is around anomaly detection. This is a big one that's fueled a lot of the uptake of AI, looking at lots of use cases around real-time asset health monitoring and analysis, asset predictive and preventative maintenance, and also vehicle use monitoring. So, where are your mobile assets and how are they being used throughout the day or overnight? Fourth one around recommendations. So, having these systems be smarter and make suggestions to us poor humans about actions that could be taken based on risk-based issue detection. So if you do detect an anomaly, there may be 2 or 3 different activities or actions that could be taken to rectify that situation, and having the system provide that insight to the human operators. Workforce deployment and schedule recommendations. So again, where should we be staging our workforce to be able to get the most work done in a day, whether it's daily operations or again, event management situations. And then crew matrix recommendations. So again, looking at that planned workload and making recommendations for the crew compositions, contractor use, whatever that may look like, and just making it easier to do stuff that takes a human, maybe months or days to do, which a system can do in minutes or seconds. Number 5, contextual knowledge, helping users easily and more intuitively navigate software. So the more intelligence we build into software, the more complex and challenging it can be to navigate through all the various features. And having AI-powered contextual user guides, being able to quickly and easily find or execute a task or command. And similarly, helping users complete quick and accurate data capture and ensuring they're working not only efficiently, but safely by following company business processes and smart guidelines with smarter technology. The final area that we're looking at investing in is around content generation, and AI really lends itself. We've heard of generative AI with the ability to automate some of the capacity planning adjustments that are needed to meet demand. So if you do have a schedule or plan built out for the year, and having a system be able to adjust all of those capacity plans to meet that forecasted demand. Offering personalized training materials. So based on my knowledge and my journey through the organization, being able to automate and tailor some of my training guidelines. And finally, automating purchase order and work order creation based on certain triggers. So with all of that in mind, an end goal being not just technology for technology's sake, but really improving the customer experience, increasing the utility's operational efficiency, and opening up for them new revenue streams for our customers.
That is a mind-blowing amount of visibility that those various aspects provide for a utility. It's quite incredible to think of an organization functioning without that. It's almost like, how have we coped with ELIZA up until this point? I think my next question is, Carol, what are the risks associated with deploying these kinds of tools within a utility? Or should I say, of not deploying it? I mean, clearly you will lose such a competitive advantage, amongst other things. So let's start with understanding, are there risks involved to deploying AI?
There's always the flip side of the coin, isn't there? With any new technology, there is the risk of unknown or unexpected consequences of adopting too quickly or without sufficient guardrails in place. We all know how critical the grid is to our daily lives and the economy. This isn't an industry where big risks without safeguards are rewarded. It often comes with big penalties if you don't get it right. With AI in particular, while it shows great promise, the recent dive in stock prices notwithstanding, to dramatically improve utility operations, we need to be aware of deploying in an ethical manner. You may have heard of terms like unconscious bias or hallucinations, where AI models are poorly built or monitored and give us bad results. That whole analogy of garbage in, garbage out, the technology will only do what we feed it and what we train it to do. If you don't have these models built correctly, you can do more harm than good. Maybe not to the level of a Terminator level event, but not good. But turning away from all risk and deciding not to embrace emerging technologies like AI, machine learning, or even simple automation will see organizations as left behind, as AI really fuels innovation, operational efficiency, new business models, strategic decision making, and unlocks new revenue streams. It's freeing the human condition to become more innovative and focus on more strategic thinking, letting the technology do the base or the grunt work. And as the world moves away from fossil fuels, we don't want the utility to emerge as the new dinosaur. We have to move forward with the pace of innovation and the pace of change.
In order to move forward with this pace of innovation and change, it's not just about the AI, it's also about the entire digitalization strategy of the utility. Carol, can you tell us, how are utilities managing with the whole digitalization process? Is it something that they are achieving, excelling at? Is there some delay? What are your thoughts?
Like most of us, some are more prepared in embracing the change digitalization strategies than others for sure. But I think we're all learning as we go, as we chart this new course. But one thing is clear: to support the outcomes we want, we need to start with a solid architecture. AI is a huge data hog. At the core of IFS's AI strategy is having a solid data foundation. If you want to build a solid house, you start with a solid foundation and then build on top of that. On top of which is built the technical components that broker the queries and the transactions, the utility specific themes and use cases that we talked about earlier, sort of that, garbage in, garbage out. You build the foundation, build the algorithms, monitor and adjust the models as you're getting different results and be more flexible as you go. The whole point of AI, at least in my opinion, is that it enables us mere mortals to engage with very complex technology and masses of data in a natural and user-friendly way. At the interface level, there needs to be integrations with advanced technologies and leaders in this area like Microsoft's Copilot, as well as looking at building, as IFS has done, native interactions that are supporting very specific functions within our software and our business models. Now, as we explored earlier, there's dozens of use cases with more being developed all the time for this technology. To showcase just a couple that are really exciting or delivering some truly exceptional early results. I think the first is asset predictive maintenance or APM. There's a lot of different rationales or meanings behind APM, but we'll talk about it as a predictive maintenance model. You can run this with historical data alone, an APM function. But when you combine APM with the Internet of Things or IoT and AI, you get real-time performance monitoring capabilities as well as insights and recommendations on corrective actions to be taken. And if you add on schedule optimization and a field service mobility solution, you have a truly efficient and end-to-end business process emerging, supported by cutting-edge technology around your asset lifecycle management strategy. It really takes us from an annual scheduled reactive process into something that can be compressed in time and greatly reduce your costs and increase your efficiency, which is, what technology promise has always been, making us more efficient and our lives easier and better. When you're dealing with millions of assets, arguably billions of assets in the field, and data coming in from multiple sources, AI driven anomaly detection is a real game changer. Not having to sift through reams of information, images, or data to find that needle in the haystack really saves not only time and money, but it really improves, safety for the community and the workforce, reliability of the grid, and your customer satisfaction metrics, which the utility is measured on. Next up, I think there's AI-backed schedule optimization. I briefly mentioned that under the APM track, but this has been around for a while now. But it's a real game changer. I think you're seeing the utilities embrace schedule optimization like they never have in the past. I think a lot of people rolled out scheduling and route optimization tools in the past and used it just for the Gantt to drag work onto it. But now with the reduction in workforce and the increase in workload, it's really becoming an imperative to embrace this type of technology. And IFS's award-winning PSO solution, our planning, scheduling, and optimization solution, is that dynamic AI-powered schedule optimization that delivers results like a 35% reduction in travel time, which is huge not only for efficiency but also those ESG metrics. And a 300 to 1 ratio to dispatchers to technicians. And that sounds mind-blowing. We've always gone for a 10 to 1 or 100 to 1. But when you start breaking out the barriers and saying that you can literally have 300 field technicians monitored and managed by a single dispatcher, that's a real shift in business operation and efficiency. And you look at almost a 50% reduction in contractor spend. And when we see utilities, I talked to some that are using upwards of 60% contractors as their workforce, both extension and for capital projects. That's a huge savings. We can argue about whether a utility is ready to embrace AI and automation to those levels or not, but the technology and the capability is there when the industry is ready to embrace it.
Carol, you spoke about how us mere mortals could engage with complex technology and data. I'd like to take a moment to consider these mere mortals. Perhaps they are boomers or even X generation, part of the workforce still. How are they adapting? And further to that, do we have the workforce and the skills to really sustainably drive deployment of AI and sustainably digitalize our operations?
Yeah, so you need to bring the workforce along. At the end of the day, technology is enabling and supporting people, end users of the software, the product, or the business process. So you need to bring them along on this journey. And depending on who you're talking to, it's either with great fear or great excitement as we introduce this new technology. And as with a lot of new technology, AI will eliminate some jobs. It's inevitable. Consider AMI, automated metering infrastructure, and the meter reader. The meter reader is a dying art and a dying role, but that doesn't mean that there isn't just as many or more jobs within the industry. So it's a shift as opposed to an elimination of a position for a human. We're just eliminating some of the redundant or grunt work that nobody likes to do. It really opens up new opportunities and frees up bandwidth for people to do their current jobs better or at a more strategic value-added level. I mean, a lot of the work that AI is tagged to take over is truly mind-numbing work. Who wants to sift through millions of asset images looking for anomalies by hand? Isn't it better to let the technology do that and leave it to smart, empowered people to review the results and take the necessary corrective actions?
Indeed, well said. And it's quite interesting and thought-provoking because we're recording on a platform that can actually imitate my voice and record a podcast. I don't even need to be there. So it's really fascinating times that we're living in. Carol, what does the future look like? If we consider 10, 20 years from now, the roles of humans, the roles of machines, and the relationship between the two, how does that look?
Yeah, and we're seeing a lot of lawsuits and challenges emerging as AI develops. Because as you said, there's challenges with being able to replace people altogether, and I really don't think that's the case. We have to put those guardrails and safeguards in place to make sure that it is ethically rolled out. And we protect people's IP and intellectual property to their own image and face. We're seeing, the impacts of deep fakes and whatnot. We need to prevent that and protect, but I don't think technology will ever replace people. It will just make us smarter, more efficient, and ideally more satisfied with our work life. Change is hard, and we need to manage and help people through the change. And that will likely include retraining and career path planning, so no one feels threatened, but instead embraces technology as an enabler, taking us into our future.
Carol, what is the most exciting part of your job?
I think it's always, I'm a change agent, so I'm not threatened by change. At a certain point in everyone's career, I think we get very comfortable in, the status quo or things that we know. Frankly, for me, it's always, a little bit more interesting to be living on the edge of the excitement of change. The best part of my job is looking out and seeing what's happening. Certainly, there's a lot of challenges with that. Nobody is enjoying what's happening with climate change and all of the impacts with major events and storms around the world and the threat to the planet. But what I find exciting about that is being able to do something about that in my own corner of the world, if you will, looking at those challenges and seeing, well, how can we adapt and address them? And the wonderful thing about the human condition is that we are very adaptable. If it's too hot, we invent air conditioning. If it's too cold, we invent, heat pumps and ways to adapt our indoor climate. I love being able to help this industry with new technology and solutions that will enable them to do better in the future.
Indeed, on the edge of change, and your role and the role of AI will have far-reaching impact. So a very exciting space to watch, and we will certainly be keeping an eye on this space in the future. Carol, thank you so much for joining us today and talking about this exciting topic. It has been fascinating.
Thank you, Pamela. It was great to be part of this with you and enjoyed the conversation.
Thank you. And to all of our listeners, thank you for joining us. Until next time. Thank you for listening to this episode of the Energy Transitions podcast, brought to you by Enlit and Friends. That's a wrap from me, Pamela Largue, and our producer, Kamo Motse. We hope you can join us next time. Visit enlit.world or subscribe for more episodes.